Hello, welcome to all. Uh, this is for forward bias for silicon diode. For this circuit diagram, um, forward bias characteristics. See here, this is ammeter and the voltmeter, and this for a diode. So now we have to plot the graph for VA characteristics of diode. This is for a simulation lab. For the simulation lab, first we have to set the diode. We have to choose for select diode. 1N4001 you have to choose for that. This is from silicon diode. The voltage is 0.6. First we have to set the DC voltage. Here the DC voltage varies from 0 to 5 volt. So now you can set for the voltage 0.2 is the minimum voltage. First we have to fix it, and then we have to fix the resistance value. You can adjust this point, and you have to vary the value of resistance. You have to fix it for 1K. You have to fix it for approximately 1000. Okay. So we already discussed this. The forward bias characteristics. The positive is connected to the positive. It is called as a forward bias. Positive is connected to the positive, and negative is connected to the negative. And this diode is parallelly we are connecting a voltmeter also. So we can vary the voltage and we can measure the current value. And what is the forward voltage? We are giving the input for voltages, and then we can measure the current voltage also. First we are looking for that the minimum voltage is 0.2, and then we can measure the current value for this resistance of 1K. Then you have to put add to table. Then first initial voltage is 0, and the measuring the current value is also 0. We can plot the values. 0, input voltage is 0, output current is 0. Now we can vary the DC voltage 0.2 to 0.4. The resistance also the same, don't change the resistance, and we have to add the table. There is no changes. It is also appear like as 0 because minimum voltage is what is that 0.6 for silicon diode. So now I can vary the value of this one DC voltage up to 0.6. We have to add for that. There is no changes. After 0.6, the current will be varied. 0.8. I got for that. Now we can add to the table. So the input forward voltage is 0.53 and for the forward current 0.17 milliampere. Then we have to vary the voltage 0.8 to 1. Now you can add the table. Then we have to add the value of 1.2. Then we can add the table. So like that we can increase the voltages, and then we have to measure the current. See 1.2 to 1.4. Then you can add the table values. 1.6. 1.8. 2. 2. So what is the maximum voltage is 5 volt. So like that we have to add the voltage, vary the voltages, and then we can measure the current value. After that we have to plot the graph of VA characteristics, VE voltage and current graph. So So like that, we have to vary the voltages. So we have to reach the maximum 5 volt, and then we have to add to the table, and we can measure the current value. This is for forward bias. For these values, we can plot the graph for forward voltage and forward current. So you have to put the plot, then we can get the graph. See, in x-axis voltage is there, in y-axis current we are taking for that, and then we are varying the voltages from 0 to 0, 0.1, 0.2, 0.3, 0.4, 0.5 up to 0.6. There is no changes of current. After that, the current will be gradually increases. See, this is called as a forward biasing. This is called as a forward biasing. This is called as a VA. So here the x-axis we are taking for a V voltage, and y-axis we are taking for a current. This is a forward bias characteristics. See, now we are going to learn about the reverse bias, simulation lab, virtual lab. In this reverse bias, the diode polarity will be changed. Okay, positive is connected to the negative, and positive is connected to the negative, and negative is connected to the positive. This side, in left hand side, the ammeter is connected here, and resistance also connected here. In parallel, we are connecting a voltmeter also for this diode. And here we are choosing for diode is a 1N4001. So initially we have to first we have to fix for the resistance value. For this resistance value, we have to fix for 1K, 1000 ohms, and we have to vary the DC voltages. This is a circuit diagram. We already discussed this, and here we have to increase the voltage of 0.2. From initially we have to fix it for 0.2. And then we have to rise the voltages gradually. When we rise the voltage from 0.2 to 5, because here the polarity will be changes. When we increase the voltages, sometimes the diode will be broken because of the heat will be produced in the diode. See, now I can vary the voltages from 0.2, and resistance is 1000 ohms or 1K. Now I add the table. For the reverse voltage, we are giving the reverse voltage is 0.161 and the reverse current is equal to 0.1. Is a 0.1. Now I can vary the DC voltage from 0.2 to 0.4. 0.5. Okay, now you can simply vary the values. I give a small demo to you. Let's say it is 0.5. Then we can add to the table. The 0.459 reverse voltage is there, and we can measure the current value, reverse current value 0.100. Now I can vary 0.5 to 0.8. Then we have to add the value to the table. Then I can vary the DC voltage 1.5. Then we have to add the table value. So similarly, we can increase the DC voltage to 0.4. Then we have to add the table. Then 3.1, 4, 5. See, there is no changes of current. We are getting for the same value, because in reverse bias we already discussed that. In reverse bias we are giving for a voltages to the diode. The depression layer will increases. That means there is no flow of current. That means diode act like an insulator. When we are giving the voltages to the diode, depression layer will be increases. That means there is no flow of conduction between the material and the material. That means this act like as an insulator. Okay. Then we have to plot the graph for this diode. There is no variation of current when we increase the voltages, reverse voltages. So this is called as the reverse bias characteristics. Now we can You can vary the DC voltages. Now you can vary the DC voltages. Then only we can plot the VA characteristics of diode. Okay, you can try it for the simulation for this link.